Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hello, and welcome to the SEI Podcast Series. My name is Forrest Shull, and I'm the lead for Defense Software Acquisition Policy Research here at the SEI. And I'm joined today by John Robert, the Deputy Director for our Software Solutions Division. And very excited. I know John and I have been looking forward to this conversation for a long time, given how timely the topic is with all the things we see in the news every day. So we're here today to talk about societal scale systems and the engineering that goes into them. So welcome, John.
Thank you so much, Forrest. Happy to be here.
Great. So one of the things I was really privileged to do recently was I was the co-lead for a IEEE Computer Society technical forum on, societal scale systems, but specifically looking at misinformation, disinformation on social media and digital media platforms. And so I've really had the chance to see that this topic that we're going to be discussing today really resonates. I think there's a lot of our folks in the computing profession that are just concerned citizens, and see these issues and understand that these are computing systems that we're talking about, and want to know what to do about it. But I've also seen, obviously, this is a very big business issue, but also from the point of view of policymakers and government folks, a lot of interest in understanding, some of the harmful effects, that go along with the good things that these societal scale systems do, and what, if anything, we might need to do about it. So, with that, let's take a step back, though, and talk about what exactly societal scale systems are. So I wondered if you wanted to take a shot at the definition there, John.
Sure, Forrest. Thank you. So we've had some conversations as a team on a report that we'll talk about in a minute. But the way we decided to define societal scale systems is that they are fundamentally about the challenges of modeling human behavior at scale when people are integral components to the system. So in other words, they're not just people that are using the system and clicking buttons to provide simple inputs. They're really an integral component of the system because the system is designed to really create human response, such as engagement or other things that we'll talk about. Companies have developed such systems, for example, in social media to generate engagement and to generate financial revenue, but they can also be used to influence humans in other ways too, which we'll talk about. So some examples include, social media platforms, such as, all the things we've heard about, Facebook and things like that. But there's also examples in other kinds of organizations, for example, healthcare, where there's, Fitbit and other kinds of things where there's engagement to create human behaviors that are positive behaviors, but there's really the software is designed to create that engagement for health benefits. And then there's also, other examples too, for example, virtual reality, the metaverse kinds of things, and even future topics like smart cities, which is one of the things you've talked about before, how smart cities could be used to create new types of engagement with users and influence human behavior in new ways.
Great. Yeah, and I think a lot of what you mentioned there was important, but the one that always strikes me, I guess, is that phrase "at scale" that you mentioned. And I think, some of these things are not new, and I think we've been used to, interacting with computers for a long time. But the level of influence they have and the ability to impact things really at the societal scale, I guess, is quite new and I think kind of unexplored territory in some ways.
Absolutely. The impact that these systems have on our daily lives is just really huge now. I mean, there are usually hundreds of millions, sometimes a billion users of some of these systems on a daily basis. So the kinds of impacts they're having on our society are growing. And some of these systems are engineered to create, new kinds of behaviors with people. And so understanding how these systems are engineered is a key part of software engineering over the next decade.
Great. Yeah. So let's kind of explore that part of the engineering there for a moment, because I think one of the areas that you and I started talking about these things first off was when we were both involved in the National Agenda study that SEI did, looking at kind of the future of software engineering. And so I'd be curious if you wanted to talk about first what that study was, and then maybe say a little bit about how these societal scale systems kind of fit into that larger view that we had on where software engineering as a field might be going.
Sure. It was really interesting. So the SEI, the Software Engineering Institute, is a federally funded research and development center to advance software engineering for the Department of Defense, but also for the software engineering community in general. As part of that mission, we started a study in the very early parts of 2020, so January of 2020, to really look at the next decade, the next 10 years of software engineering research. So this is research intended to build the future software systems, to look at where we are today, look at the challenges that are ahead, and what kind of research is needed to create the systems of the future. As part of that activity, we looked at different types of topics, different types of systems. And one of the topics that came about was this area of social media. And we started to realize that these types of societal scale systems were really a big part of what we were living in at the time. I mean, the pandemic started shortly after that. We as a society and around the world were seeing different kinds of effects of these systems on our society. And our interest, again, is not on any one aspect of the debate about these systems, but on how to engineer these systems. What are the new challenges about these systems? And so as we started to explore that, we realized it was hard to unsee some of those challenges because when you peer under the hood, they really are different kinds of systems. So, for example, as we talked about earlier, when these systems are designed, they're created using psychology mechanisms to create a response with users and engage in a new way, not just as people providing input, but really to elicit a psychological response from the people using the systems. And that's in the one-on-one, software to a one-person individual. But then if you look at that at scale across many, many people, predicting how these systems behave at scale is really a challenge. And that was part of what we were seeing. So as we explored that idea, there are some new challenges here. It's a new type of system. And looking ahead how to engineer these systems, we saw several areas that we'll talk about in a minute that needed to be explored. And it was really interesting because we realized just how much these systems are a part of our future.
One of the things I really appreciated about the study was that it was really community driven, and so it was a great opportunity to kind of interact with a lot of different segments of the computing and software engineering, population here in the United States. And I mean, to your point, that was why societal scale systems ended up one of our top 6, themes, was that it was one of these things you just hear over and over again, from the folks that we talked to about looking into the future and seeing where the interesting problems and challenges are going to be. I was going to make the connection. I mean, last year I was really had the time of my life actually being the IEEE Computer Society president, and same issue. I mean, one of the things I really loved doing was going around and talking to different parts of the computing profession, that are represented there in the society, and just the amount of interest and even anxiety, I guess I heard around some of these systems, especially the digital platforms. Just it's in the news every day. I think people care about the worry about the types of information or misinformation that get pushed out about things like vaccines, about the war in Ukraine, about all kinds of issues, and recognizing that underneath it, these are really, like I said before, computing and software engineering systems, that we feel we should, as a profession, have something to do with it. So I think there's a lot of interest in these issues there, and probably a growing sense of how we engineer these things better as we go.
Very much agree. And I think the aha moment that we had is thinking about people as really new components of a complex system of systems, and thinking about how when we engineer these systems, we engineer them to accomplish certain types of properties like safety or security or reliability today. So what are the software engineering activities needed to construct and engineer these systems in ways that are also safe or predictable in some new ways?
Yeah, I think that parallel with safety and security is an important one, actually, because, I always say underneath it all, I don't think that these are really natural phenomena, although sometimes we treat them as like immutable ways that the systems behave, right? So we understand how to engineer systems, and we make specific choices to engineer them to be safe and to be secure. And we have trade-offs that go into all that. And I think, as we go forward, I think there'll be a lot of work in this area. And I think we'll understand better the engineering underpinnings that have to be done to understand, how to make the systems more fair, less biased, whatever the new set of abilities in a way is going to be.
If I could add one more thing, I think one of the other aspects, because you talked about the IEEE community and the input you were seeing and the challenges people were talking about, I think one of the things we heard from the advisory board of the National Agenda Study that I mentioned before, which included people from across industry, Department of Defense, government, DARPA, et cetera, a lot of different perspective about this new challenge, this new area. But one of the things that really solidified for us that this is really an area that needs attention, and from a software engineering perspective, is that there started to be reports, papers, and even documentaries, such as a Netflix documentary, A Social Dilemma, that was created by software developers, people that were creating these systems, people that were maintaining these systems, part of the startup companies, and they were asking questions as well that we felt were very profound in terms of the software engineering challenges ahead.
Yeah. Yeah, it's very similar to, I think, one of the things we see through the Computer Society. Oftentimes in the past, I mean, it's always been a technical community, obviously. And I think a lot of times we're somewhat guilty of treating the technologies that we develop as if they're value neutral in a way, or that they're always going to be used for good. And exploring this issue now through the larger community, I think one of the things that we quickly realize is you bump right up against freedom of speech, kind of some of these other social choices, which is why we had some really good conversations at our technical forums with, a congresswoman from the U.S., an MP from Canada, a UK government advisor. It strikes me that people are aware of these issues, they're concerned about them, and there's a lot of social choices that have to come into play here. Just as on a tangent, I think it's really important for us as technical folks to be part of those conversations. I think people are hungry to do something, and people are willing to do policy in these areas. And I'd really like the technical folks to be part of that and have a voice, so that they can be well targeted and as effective as possible when they're needed.
Very much agree. I think the conversations that you're talking about are also very cross-disciplinary, where there's a need to engage with people outside of the software engineering or computer science communities to the other communities of psychology, sociology, even economics, and other kinds of disciplines to really help shape, the software engineering techniques and tools needed to solve some of these problems. It is interesting how software engineering as a discipline has needed to extend itself. We use the phrase build software, think systems, build software, which means that we have to think at the system level and understand the properties and behaviors we need to have happen, and bring that down to the software architecture, software engineering activities that we need to pursue as professional developers. And so with that in mind, it really reshapes, how we think about the boundaries of the system and these kinds of things, but also shapes, going forward, what are the new techniques or new areas that we need to have available in our tool set to build these kinds of systems.
So I think bringing the conversation back around to some of the things we can be doing today, I think that last point was a great segue into kind of the more constructive part of it. I think one of the key things that's always at the top of the list is that kind of multidisciplinary conversation that you just talked about, John, because I think it's always important for us as software engineers to have that domain expertise and be able to work across the discipline boundaries. But I think this is an area where it's even more challenging and more important than ever. I think some of the other things I see going on myself is some work on just kind of better tools to monitor the content that goes out there. So not necessarily that anyone's trying to get into the chain of it, and kind of disrupt the communication, but just understand what's actually happening. And one of the things I was really surprised but interested to see through the Computer Society work is that there's kind of this whole population of small companies that have sprung up, which are really trying to do the work that some of the larger platforms aren't, in terms of monitoring, in terms of testing, whether bad content really gets through the filters, and just have a sense of what's out there and be able to report on it, because I think that level of insight is already very important for us to do something with it.
Agreed.
And then beyond that, I know that the Computer Society is starting some work on standards in the area, trying to look at, what does it mean technically to be a trusted news source, or how might I do some research, some rating and some assessment of different news sites in order to say which ones are more, say, trustworthy than others. And I think that's a really hard and challenging thing, and obviously a lot of opinion gets into that. But at the same time, it's a sense of the community doing what it does best, which is coming together to argue and hash out some of these issues and hopefully make some progress, even if we can't get the whole thing done.
I very much agree with all of the points you made, Forrest. And I think one of the aspects of this conversation, which I found so fascinating, is, a lot of times people think that the discipline of software engineering has to change to create a new type of system. Well, these systems have been created. They exist. And there will be new types of systems in this category over the next decade, with startup companies, et cetera, as people extend into new areas. So what's really needed to advance software engineering isn't how to create these systems, but how to create them better and with a better understanding of what are the trade-offs that are happening when you build these systems, but also how to meet the society expectations for these kinds of systems in terms of privacy and bias and security and other kinds of concerns. And so understanding the new challenges and new qualities that are expected by society through those policymakers, et cetera, for these systems is critical. And then having the software engineering techniques and discipline to really build and move that direction is critical.
That's great. I think one of the things that touches on too is just the need to be what's the word I want? Conscientious, as engineers, but also as kind of citizens, when we use these sites, to have those high expectations, about what they should be doing in terms of privacy or what kind of information they push through, and at least be able to make informed choices, about what trade-offs we're willing to make on our day-to-day basis.
Yes.
So this is good. I mean, this talks about what we can do today with the systems where they are, but I think one of the things I wanted to circle back on was, I know you've been doing some looking at kind of where things are going. And I think the National Agenda Study also looked at where things might be headed in the next 5, 10, 15 years out. So I wondered, I think in a recent blog entry, it kind of pulled together some thoughts on 5 important research areas that are informing these types of systems. And I wondered if you could present a little summary of that.
Sure, happy to. So there are several areas, but as we talked about, they're expected to be cross-cutting and cross-disciplinary for all of them, working outside of the software engineering and computer science communities with some of the other communities. But one of the first areas is new quality attributes and architectures. So one of the challenges with these types of systems is that these societal scale systems have new quality attributes that are not well understood. Most software architectures today are created with these trade-offs in mind, with well understood quality attributes such as performance or security, reliability. So the research area that's needed here over the next 10 years is really a focus on the new quality attributes for societal scale systems and understanding the relationship of the design decisions as these systems are created with the behaviors that can be expected after they're deployed and being used. And so understanding both what are the attributes that need to be engineered, but also how to measure those attributes and how to build to create and accomplish those attributes is really critical. And that's new techniques in software engineering are needed to really do that, because today, when we've seen in our recent history that there are a lot of challenges today with these kinds of systems. And trust and privacy and bias are not necessarily new, but the challenge of predicting these kinds of properties at scale, like we talked about, and really understanding, what the consequences are if the systems are built to really focus on the individual interactions and engagement without thinking about the larger scale problems or properties. It is really a new area that we have to explore and build those new techniques. The second area, if I could go through that, keep going, developing a theory of socio-technical knowledge creation. So this is a little bit different kind of thinking, but it's the idea that we got from Jim Herbslip at Carnegie Mellon, who is a professor leading the teams there in the newly created Society Computing Group. But one of the things to think about is that kind of like a funnel. A lot of the data that we see today in these societal scale systems are creating new communication mechanisms, new types of information flows. And that's wonderful because it creates, connects people around the world in different ways and new ways with many, many benefits. But one of the things that happens is as the data is going through these new information flows, that it's not sort of processed and then integrated into society's knowledge base in quite the same way. So we usually think about, reporting in a newspaper or a magazine or TV and how that's, processed and sometimes vetted for information. And then that makes it into sort of society's understanding of a challenge or a problem or a topic. But now there's new pathways. And so how do those pathways work? What are those pathways, inputs into those pathways, and how they create new outputs in terms of society's knowledge is really important. And I think this is another thing that comes up about our role for the Department of Defense, because, there are national security challenges if we don't understand this relationship about societal scale systems and the inputs, and then what does it change in terms of society's understanding and knowledge set as an output. We really have to have ways to understand, measure, track these kinds of shifts and make sure that, for the safety and security, things are transparent and not happening, totally behind the scenes without understanding what's going on.
Yeah, no, and that sense of understanding, I think, is where, again, when you do it at scale, where so much of the challenges come in, right? I think it goes far beyond being a technical issue, I guess, when you start to look at AI and ML being able to help you identify some of the problematic content that might go out there.
Right.
I think that there's enough nuance that's hard to do when you're in English. But then when you think about these kind of global systems, and you have to worry about things in Indonesia and all kinds of populations where we might not have that kind of experience at headquarters, it becomes a real challenge about how to manage that.
Excellent point. I agree. When you think about the global challenge in terms of languages, different types of data, like a picture is different than textual data, for example, and video is different from that, and understanding how these different types of data sets are filtered through new communications channels, it's really a wide open area of research. There has been some publications, and we cite some of this in the report. Rand Waltzman, for example, had done some work in this with DARPA in recent years. So but more research is needed. That's the point, is that more research is needed in these topics to build the tools and techniques for engineering these systems going forward. Mm-hmm. The third area that we identify in the blog is adherence to policy. So as you were mentioning before, policymakers around the world are talking about societal scale systems and debating, sometimes even creating new policies or rules to govern societal scale systems. So we identify in the report again that research is needed to really help formulate and validate some data-driven and openly understood techniques for industry, government, and society to really have a technically grounded governance framework. Something that is not just sort of a blunt instrument, but is something that is really informed by the technology, underlying technologies, and what are the opportunities and risks of those technologies, but also, really trying to look at, going forward, what are the trade-offs? A software engineer should not necessarily be making a really fundamental trade-off about privacy versus, some other quality. They need to be following some general guidance and policies from the governments to the point that that's needed, to their company, and then also be transparent about some of what's happening behind the scenes. So again, we're focused on not what is the policy, but creating a technical framework so software engineers have the skills and the training and the tools they need to create these systems, knowing that these policy aspects need to be built in. Mm-hmm. And then a fourth area is experimentation and testing. Another big challenge with these systems that became apparent as we talked to folks is that these societal scale systems really operate at such a scale that really creating a test environment is extremely difficult. I mean, replicating a system with replicating a system with so many different types of operators and users with so many diverse opinions and perspectives is almost impossible. So creating a test environment, it has limits. It can be done, but it has limitations and constraints, and that challenges the way we think about testing a software system, which typically is done in different stages, from unit testing to integration testing to operational testing, et cetera. So a deeper understanding is needed here about how to test and what does it really mean to test a societal scale system, and how experimentation can be done on operational systems. One of the things that is done in these kinds of systems is what's called A/B testing, where out of the many millions of users, a slightly different version of the software may be released to different users, and the company or organization that releases software can test whether or not certain small changes to the software results in a desired response that they want from users, like for engagement or clicking on an ad or whatever. That's called A/B testing. What is interesting is that is a form of software testing, but it's because it does result in changes to the software, but it's done in the operational system. So we really need to explore what are the opportunities for testing in an operational environment, but that also includes what needs to be released to the public in terms of transparency and openness about the kinds of testing that is being performed on a day-to-day usage basis. So testing is another huge area. And then finally, I'd like to talk about software development using these types of systems. So one of the sort of niche areas, so it's just a small sliver of the large scope of these systems, is when these societal scale systems are used for developing new software. So we think today about software being developed not in a small team, but by a distributed team, typically a globally distributed team, and especially with COVID, distributed even within a certain city where everybody may have gone into an office, they may be now scattered all around. So that distributed software development environment is really an interesting opportunity to apply societal scale systems where an individual software user or software developer, is not just typing in code. We're already seeing today that there is AI-enabled kind of support for the developer that provides on the integrated development environment, provides suggestions about typing as you're typing and uses the context of your development environment to make suggestions for certain parameters, etc. The next evolution is likely applying the societal scale kind of influence to where a developer could be incentivized to do certain things. Maybe the developer is incentivized to develop software faster or do more releases in a day. Maybe a developer is incentivized for other concerns like quality, fewer bugs in the software. We talked about how at some level, these things are already happening. If someone thinks about a software developer getting like a year-end bonus for a job well done, at that level, yes, some things are being incentivized today, but the opportunity with these new systems is that there could be far smaller granular incentives on a weekly or even daily or hourly basis to the software developer to take certain action. So the research that's needed here is, how effective are these new techniques to really enable the desired results or benefits, and then also as we look broadly for the software engineering discipline, what are some of the risks involved with that kind of activity?
Good. Now that example, especially about the incentivizing, I think that's a theme that's kind of come up a couple times in this conversation. And it's interesting to me because I think sometimes we look at these systems affecting human behavior as like a weird side effect. But no, actually, the point of these systems at scale is exactly to influence human behavior, whether it's to, like you said, to produce better code, conserve water in a smart city, have traffic move more smoothly, or trust the system enough to use it and make it part of your day-to-day routine. So it's again, it's one of those things where I think it's important that we have those cross-disciplinary conversations to understand these types of tools and the psychology behind it, and when it's a good use of it and when it's a little bit something we should be concerned about.
Agreed.
So I think that that's also a good segue into the next question I had, because I think it's kind of an interesting question about how people can start to work or get involved, in this type of research. And the societal scale systems are strange in that they're all around us and we move through them every day, but it's somehow hard to get accessible to them when they're proprietary, they're commercial, they're kind of behind some kind of protection. So I wonder if you have thoughts. I think you've already mentioned some resources that people might use to get started in the area.
Sure. I think the resources are growing. I think one of the things that I found fascinating are documentaries like the Netflix, The Social Dilemma, which is for software developers, I think an interesting insight. I think you mentioned the IEEE activities, which is great to get involved with professional societies. And because professional societies will be a key part of how to work through these questions and develop maybe new solutions. We also see that a lot of universities are starting to have or have recently had a shift to really the societal scale computing kinds of concerns. Carnegie Mellon, as I mentioned, Jim Herbst changed they changed the name of their whole department, aligning with the society kind of impacts of software writ large, and we've seen at Stanford and other places similar departments that have been in existence, looking at more broadly how software engineering touches all these other disciplines. So I think there's opportunity there for anything from coursework to research. And there's probably many others. I think there's some books that you may have.
Oh, yes. I have visual aids, as a matter of fact. Okay. Because I often say there's a lot of good stuff out there, not all of it written really in deep technical direction, for an engineer, but things like Weapons of Math Destruction, which has the best title ever, I decided. Yeah. One of the things that book talks about, again, in a very accessible way, is the use of these algorithms, how they get embedded into large systems. And then you have these algorithms that are at least informing, sometimes making decisions, but they're not auditable, so that you don't often get the chance if you're being discriminated against. If there's an algorithm, let's say, that's making decisions about who gets to be alone because who looks risky, or who gets to be let out on parole because we have some data about recidivism rates. If those things are not going in your direction, you don't often get the chance to query the algorithm. You don't get the chance to see why that's happening. And they get wrapped up in a whole level of, prestige and accuracy that, might not actually be the case, depending on how they were developed. And so I think it's a message to us as engineers that as we build these systems and encode the algorithms, there's issues about transparency, about fairness, issues like that we have to consider, as we go forward. And the other book I have, which I really liked, again, not even so specific to societal scale systems per se, the engineering of, but a book called Invisible Women. And what this is about is not the algorithms so much as the data sets that they were trained on. When you have these algorithms, again, making decisions about what kind of medical procedures to recommend, let's say, and they've been trained on data sets in which the female population is underrepresented or not represented at all, it has the possibility of really driving poor recommendations. And again, because we focus on the engineering of the system part of it, and maybe not so much the underlying data set, these are ways that pernicious bias and other problems can creep into the systems without us even realizing it sometimes. So I'm glad you mentioned the Computer Society work too, because the technical forum, we have a list of resources that we've compiled through those conversations that are available for folks. And we'll make the links to this and the other resources available on our website afterwards. But I think there's a lot of things there that people will find interesting, just to kind of hear different perspectives on the conversation and think about how these things might come into our systems.
I think you're right. The multiple perspectives that are needed here is really interesting because I think it's still unclear what all the dimensions are that are needed to really inform an understanding of the problems and create some new solutions. Mm-hmm. And I think everybody is realizing our increasingly dependent nature as a society on the reliability and safety of these systems. And so I think it'll be an incredible area of research and exploration over the next, certainly 5 or 10 years.
Good. Yeah. And one last thing I thought of too is that I think especially for educators in software engineering, I think there's a real opportunity here really to do a better job of bringing in kind of what it means to do ethical engineering. And I'll just from my own history, I'll say that I think it's always been a part of the software engineering curriculum that I've seen, but it's always kind of treated as an afterthought or as an add-on. And one of the best practices that I heard of from some educators was the idea of team teaching a class and really bringing in someone with the expertise in ethics. I think a lot of times we think that we can understand ethics and we'll teach it to our classes, and we kind of give it short shrift because it's a very it's a very deep area, just like our software engineering one. So bringing in someone who really is that expert and being able to have them be part of the dialogue for the class, that you get to see the give and take of some of these conversations, and how different issues might get thought of differently from an engineering and an ethical side. I think there's no necessarily one right answer, but understanding that there's a process that you go through to think about these things and worry about how they might come into play is still a very important part of the education that we need to be training people on as we go forward.
Absolutely agree, because several of the conversations that we had in creating a report is we realized as we thought about possible future scenarios. Again, our intention is not to try and predict the future because that's very difficult in the technology space. But we looked at future scenarios and possible future scenarios to give a sense of the broad set of possible futures that we face. And one foundational aspect is that this concept of people as components, of using influence kind of concepts and psychology approaches to really shape the user to do certain things or to take certain actions. That simple idea can be extended to so many new areas that we haven't really seen yet. I mentioned the software developer and how to shape that. We talked about, smart cities and healthcare. I mean, one can imagine in, financial, cases, how that might be applied. It could be applied in all kinds of work environments. And so the ethics concepts that you just highlighted will really be critical to help everyone, including software engineers, understand what are the opportunities for applying these techniques in new systems, but what are the risks and maybe the limits that need to be applied as we look at how this can be used in many domains.
Mm-hmm. Great. So as you mentioned before, John, I think the SEI has a very specific role, in the larger research ecosystem in the U.S. So I wonder what's next for us in this area. We talked a lot about things that people can do and awareness and where the larger community or where the larger trends might be going. What's next for SEI here?
That's a great question. We continue to be very interested in exploring this area. We do have research, fundamental research that we do and applied research we do, and then work we do with customers. So we are certainly exploring the space of how the societal scale systems can be used for software development environments. So what does it mean for software developers and software development environments to really apply this? Where is it effective? Where is it not effective? Doing research to explore that space. That's certainly an area we're going to be tracking and exploring over time. I think as we look further, the use of AI in these systems is an aspect. One of the other areas that we highlighted in the report is what's called AI engineering. That is, how do you construct AI kind of a system that have an AI component in it, and what does that mean for testing and for all the whole software lifecycle when we add AI components to it and ML ops and things like that. So as we look to those kinds of concerns, all the concerns that have to do with using AI, or many of the concerns have to do with AI, can also be applied here because there'll be new approaches, but new risks and concerns. And so that'll also be a theme, I think, in our research going forward.
Great. Well, thank you so much, John, for the time today. I think this has been a great conversation, and hopefully we've managed to convey at least a little bit of the excitement I feel, because I think these are really exciting and important challenges to deal with as we go forward.
I very much agree. Thank you for the time. And I think, as you said, it's really a key area for software engineering going forward.
So for our listeners, we will include links to the transcript in the transcript to the resources that we mentioned during the podcast today. So you'll be able to access those and read more about it if you're so inclined. And finally, a reminder to our audience that our podcasts are available on SoundCloud, Stitcher, Apple Podcasts, and Google Podcasts, as well as the SEI's YouTube channel. So if you like what you see and hear today, give us a thumbs up. And thanks again for joining us.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.